They don't. Some are horrible, sometimes they're wonderful. G92 is the same thing. Hey team, this is Luke with Crusader Machining. Thank you for tuning in for today's video. Class is in session. And today we are going to continue our dive down into the world of canned cycles. The canned cycle that we're going to be going over today is the infamous G92, a simple threading cycle. Before we dive too far into it, let's head out to the shop floor real quick and see it in action. Here's an example of a G92 repetitive canned cycle in action. Let's head back in the office and talk more about it. So lately everyone's been asking me, hey Luke, what's a G92? Let's try to give a thorough and concise answer on what that is in this video. A G92 is a simple threading canned cycle that's used to put OD threads or ID threads or outside threads or threads on the inside diameter. It's a commonly used code in the world of CNC programming because of how simple the code is and how easy it is to write and modify. You determine your starting point, your ending point, your feed rate, and how many passes you need to take. How many passes you need to take varies upon what pitch thread it is. If it's a very coarse thread, like maybe 8 threads per inch, you would need a lot more passes due to the height of the thread. If it's a real fine pitch thread, like say a 64 threads per inch or TPI, you would need a lot less passes because the thread height is proportional to the length or the pitch of the thread. Those amount of passes that you take can be determined by the manufacturer of the tool that you're working with. We use Seiko and Sandvik charts that I'll put later on in the video. That'll determine your amount of passes that you take. And we're gonna cover that further in the video when we dissect the code. But essentially, start point, end point in Z, your approach in Z, your end point in Z, your feed rate, which is your pitch, and how many passes you need to take. Then you're going to find your major diameter, your minor diameter. You can use the machinery handbook to access all this information, and if you find yourself in a pinch, you can always reach out to your tool manufacturer like I had stated before. Your pitch determines the length of one thread that is cut, and it's going to be cut down if you're on the OD down to your minor diameter or your thread root. That information is also in the machinery handbook. If you're cutting an ID thread, you need to determine that highest point of an internal diameter thread that you're going to cut. Once you have all that information, you plug this into the code and the machine takes care of the rest. G92 is essentially a down and dirty repeating canned cycle that'll cut the same repetitive path over and over from your start point in Z and X to your end point in Z, either down in X or up in X based upon if you're doing an OD thread or ID. It's a very simple repeating path canned cycle. Like we just saw in the video, you're gonna start, you're gonna cut, and it's gonna come further down at X until it achieves that thread root or that minor diameter that once again, you can find that number in the machinery handbook. We're gonna go over a couple examples of ones that I wrote, and I'll explain to you how we got that information. That's essentially what a G92 is. So now let's hop into some pros and cons, some benefits of using a G92, and maybe some reasons why you wouldn't want to. This is that sheet I was referring to, or should I say that information that talks about your amount of passes specified per different thread pitch. You can pause this and screenshot it, or you can get a hold of Seiko and Sandvik and they have that same information for you. That'll give you how much material they want you to take off per pass, leading down to that finished pass. So now that we got done discussing what is a G92, went in a little detail with that, let's talk about some basic pros and cons, because the way G-code, canned cycles, programming methods work, there is not one method, code, cycle that's a cure-all, end-all that's going to solve your problem. Some canned cycles work great, other times they don't. Some are horrible, sometimes they're wonderful. G92 is the same thing. There are pros and cons. The biggest pro I would say to using G92, and I am pro G92, would be, it's simple to understand, like we had talked about before, and we'll see more when we get into the code itself in this next lesson. Starting point, your ending point, your feed rate, your pitch. Then you determine your depth of cut from your manufacturer. That's it. It's simple to write. Very simple code to write. Simple to understand, simple to write. Once you know what the code means, plug and play, boom. You're gonna see once this video is done, you write your own G92. It's easy to change, easy to read, easy to write. Another thing that leads me into this, another pro, is it's easy to change on the fly. Your depth of cut, i.e. your number of passes, etc. Very easy to change. The last pro I would say is it's wonderful for simple threads. If you're not expecting to have issues with tool life, surface finishes, or achieving a complex thread in a weird material, G92 is the way to go. So those are some pros. That's why I use them a lot. A lot of threads I make are very simple. Some cons to using G92, I would say, it's not ideal for exotic materials or complex threads. What do I mean by that? Exotic materials, titaniums, Inconel, Hastelloy. Sometimes you need a little bit more of a better threading cycle to prepare for those exotic materials or weird threads. Another con of G92 is there's no option to change your lead-in. In another video we might go over G76, which is a more robust, complex can cycle for threading, so definitely superior, but definitely more complicated. You can have different lead-ins, different methods of your tool moving in on your material to optimize your tool life and chip control. So it's another con of a G92 is you only have really one lead-in. Another one is it's not really a versatile code. This kind of ties into the previous. There's really not much that you can do with it aside from setting your depth of cut. That's it. So those are the few cons I would say is with the G92. To conclude that section, pros and cons, if you're worried about solving all of them, go with the G76. G76 is a great threading code, a little bit more complicated to understand and to use, and certain machines have different requirements for the G76 versus others, like a OSP versus a FANUC control. There would be a different G76, but it's not that big of a deal. So that's what I would say are some good pros and cons. Overall, I like G92. It's a simple code, but that simplicity is not very versatile. So now that we went over some pros and cons, let's dive in and dissect some code. So by the time we're done seeing this next section, you're gonna know all about how to read, write, and understand a G92. So here you can see we have an example of a G92 for an ID thread. The first line, we're calling up our tool offset. Then we go to our approach in Z, our approach in X, call up our RPM. Then the G92 code hits, and you can see the first pass is X.720 to Z450. That's our ending point in Z, and the F, 0.055, that's our feed rate that's determined from the pitch. And now you can see the lines underneath it. The X is moving larger and larger and larger up until eventually they get to X.735. That's the ending point that we determine from either the machinery's handbook or that thread spec. So that thread at the end of that line, that thread now is done. We go back out and we go home to a safe position. Now here's an example of an OD thread. G92 threading cycle. First line we'll call up our tool, then our RPM, then we're going to go to our approach in Z, our approach in X, and kick on that G92, X.855, Z662, feed of 71.4. So our Z starting point, our Z ending point, and our feed is 71.4. Each subsequent X line is going to do that same path of go to our approach, go to our ending point at that feed rate at those different X's until it goes down to the end and it hits X.788. It's a repetitive cycle. Now let's watch one or two more examples of a G92. This is that same G92 that we looked at the first example of an ID thread. Watch how it just repeats and loops over and over. Now this is a G92 that's slowed way down so you can see it's going bad. I want you to watch the approach and the end point. Notice that, and it's going to just drop down on X until it achieves that thread. So we just got done dissecting the code, the G92 that I wrote, and this video is coming to a conclusion. Good class lesson today, I would say. Today we did a dive further into the world of CAN cycles, G92 specifically. We discovered what is a G92 exactly, what are some pros and cons of using a G92, and we dissected some code to help us further understand. A couple recaps. For thread cutting depths and technical information, you can reference your machinery handbook and your tool manufacturer such as Sandvik or Seco. Those are all great references you can use to help to determine the specific cutting requirements and recommendations. Surface footage, depth of cut, how many depths of cut to take to achieve your thread depth. G92 is a simple CAN cycle that can be a very useful tool for CNC programmers, and I hope someone out there can gain some information and some value from this lesson. Like I said earlier, everyone's been asking me about CAN cycles and G92 and all this stuff, so I hope this helps to clear up these questions. Thank you for watching the video, and we'll see you next time.